Welcome to the arithmetic zone, and today for our math video we're going to cover the imaginary number I. So what does I even mean? Well, it's essentially a representation of the square root of -1, and if you know, you can't have a square root of negative numbers. They don't exist. So I is just used as a placeholder to represent this value. As you can see on the left hand side, I have some identities by raising I to a whole number power. So as we know, I is equal to the square root of -1, but I squared, well, that's just the square root of -1 multiplied by itself. So that actually equates to just -1. I cubed, using what we know about I and I squared, we can derive -I from I cubed. And I to the fourth power, again using the identities we know, is just +1. And the interesting thing is when you have I raised to a whole power, you can divide that power by 4 and find its remainder to determine what it's actually equal to. So on this bottom area, you can see how the remainder tells you what the I is equal to. If it's 1, it's equal to I. If it's 2, it's equal to -1. If the remainder is 3, it's equal to -I. And if there's no remainder, then it's equal to 1. So here's some examples where we're going to use the remainder to find what all these expressions are equal to. So I to the fifth power, you take the power, which is 5, and divide it by 4, and you get 1 with the remainder of 1. And because there's a remainder of 1, I to the fifth power is just equal to I, or square root of -1. Now I to the 100, again, we're going to take the power divided by 4. It's 25 with no remainder. If there's no remainder, then the whole thing is just equal to +1. Now I to the 34th power. This one's a little harder. 34 divided by 4, if you don't know what that is, it's 8 with a remainder of 2. And if you have a remainder of 2, then that means this whole expression is equal to -1. Pretty simple stuff. Now we're going to take our application of I and we're going to delve a little further by simplifying imaginary radicals. So hopefully you know how to simplify radical numbers already, but now we're going to simplify imaginary radicals where they have a negative number. So let's simplify the square root of -48. The first thing you should always do is separate the I and the number. So how do you do that? You take the square root of -48 and split it up into square root of 48 times the square root of -1, and those two expressions, this and this, they are equivalent. Now square root of -1, we already know this turns into I. And in square root of 48, we can take the highest perfect square, which is 16. We can take 16 out of it, and then a 3, because 16 times 3 is 48. So we have square root of 16 times square root of 3 times I. Square root of 16 is just 4. Square root of 3 can't be simplified any further, and we just have an I. So putting it all together, we get 4I square root of 3 as the simplified form of square root of -48. Finally, we're going to see how we can find imaginary roots in a quadratic equation. So before I teach you this, I want to teach you how you can find how many roots there are in a quadratic equation. Use the discriminant expression b squared minus 4ac, which is derived from the quadratic formula, to know how many roots there are. So putting in your a, b, and c values, if this discriminant is less than 0, there are no roots, which means that there are imaginary roots that we may need to find. If it's equal to 0, there's one root, usually repeating, and if it's greater than 0, then there's 2 roots. So let's look at an example. Finding the roots of x squared plus 4x plus 5. Now this is unfactorable. You can try it, but it's not really going to work out. And if we use b squared minus 4ac, with a is 1, b is 4, and c is 5, and we substitute in our values, you can see that it is less than 0. -4 is less than 0. That means there are no real roots. Yet the question is still asking us to find roots, so we're going to have to find the imaginary roots, the roots that really don't exist. So obviously you want to take this expression and set it equal to 0. And then from here, you want to use the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And you can see how the discriminant expression comes from this formula. Anyway, substituting our a, b, and c values, and if we simplify this further, you can see that inside of this square root we have a negative number, and that's the reason why there are no real roots. There are imaginary roots still that we can solve for. So we want to first take this square root of -4 and simplify using what we just learned. So if we split the square root of -4 into the square root of 4 and the square root of -1, square root of 4 is just 2, and then square root of -1 is I. So x is actually equal to -4 plus or minus 2i all over 2. So then we want to divide 2 by both terms, and we get x is equal to -2 plus or minus I. And because we have a plus or minus symbol, there are two possible roots that we can get out of this. X is equal to -2 plus I, and x is equal to -2 minus I. Now, you got to remember that these are imaginary numbers. If you try to graph x squared plus 4x plus 5 on your calculator, then you're going to see that the expression never actually reaches the x-axis because both of these are imaginary roots. They don't actually exist. Anyway, that's going to be it for this video. This is a pretty short video, but hopefully you guys understood the concept of the imaginary number, and it is an important part of high school math, especially in Algebra 2. Anyways, I hope you have a nice day and enjoy.